Hey everybody, Chris McClure here. We're going to now move to working with graphs, which means that we are going to be doing some work on the XY plane. So we're going to talk a little bit about that this section, where we are going to first remind you what the XY plane is. It's really going to be this two-dimensional plane characterized by having the x-axis and the y-axis which meet at the origin at 90 degrees. The x-axis and the y-axis are both copies of the real number line, intersecting at 0 for each of the lines. Of course, going to the left, meaning westbound, if this were a map, you'd be going in the negative x direction. Going to the right, or east, you'd go in the positive x-axis. Going north, you'd be in the positive y-axis. Going south means that you're going in the negative y direction. You can locate any point on the plane by going so many units left or right for one coordinate and so many units up or down to get the second coordinate. Because these coordinates are gotten by going left or right and up or down at 90 degrees, we call this rectangular coordinate system, also known as the Cartesian coordinate system, named after René Descartes, a French mathematician slash philosopher from several hundred years ago. So let's go ahead and get some practice in plotting points if we know their coordinates. First of all, the point at 6, 4, where is that? Where you go right 6 units and up 4 units. And there it is. There's the point at 6, 4. What about the point -3, -5? We're going to go left 3 units and down 5 units to get that point. How about the point 0, 7? Well, the first coordinate being 0, that means that we don't go any units to the left or to the right. We just go 7 units up. And then the fourth point, -6, 0, that means we're going to go 6 units to the left and 0 units up or down. So there's our point, -6, 0. Any questions on how to plot points? I'm sure you've done it from a previous class. Just as also a quick review is that the XY plane is divided into 4 quadrants, starting off with the first quadrant when X and Y are both positive, and then moving counterclockwise to the second quadrant where X is negative, Y is positive, and then down to the third quadrant where both X and Y are negative, and then over to the fourth quadrant where X is positive and Y is negative. Now let's talk about how to calculate the distance between 2 points on the plane. So here's kind of the idea. Let's just go through a real example and then we'll show you the formula of how this goes. Suppose that we've got the point 1, 3 and 5, 6. And we would like to know what is the straight line distance between those 2 points. Well, one way that we could do it is to kind of create a right triangle by going so many units horizontally from 1, 3 until we have gotten as far as the 5, 6 point. And then we stop until we have reached the furthest extent right that we can go. And this horizontal line segment represents the horizontal distance between the 2 points, meaning the distance, or I should say the difference between the x coordinates 5 and 1, as in 5 minus 1 is 4. So 4 is the length of that horizontal distance. And likewise, the vertical distance would be the difference between the y coordinates. 6 minus 3 is 3. So now we have this right triangle with a leg of length 3 and a leg of length 4, and we can use the Pythagorean theorem to calculate the length of the hypotenuse, which is really the straight line distance between the 2 points. So what is the square root of 3 squared plus 4 squared? It's going to be the square root of 25. Square root of 25 is 5. So 5 is the distance between those 2 points. And we will use the same sort of idea to calculate the distance between any 2 points. Basically, here's how this goes. The distance between point 1 and point 2 is going to be the square root of the sum of the squares of the differences between the x-coordinate and the y-coordinates. And if you're curious as to why this should be true, well, take a look at this picture here. Suppose that we got point P1 and P2. Now, x2 minus x1 is going to be the horizontal distance between the x-coordinates, and y2 minus y1 is the difference between the y-coordinates. And you see those x2 minus x1 and y2 minus y1 then form the length of the legs of a right triangle. So we can use then the Pythagorean theorem to say what is the distance of the hypotenuse. What is the length of the hypotenuse? Well, it's the sum of the squares of the length of the legs, right? So go ahead and add up the squares of the lengths of the legs, which is basically the sum of the squares of the differences of the coordinates, and then take the square root, and voila, you got the difference or the distance between P1 and P2. That's what this notation means with the little d, open parenthesis, P1, P2, close parentheses. If it turns out that your 2 points are horizontal from each other, meaning they have the same y-coordinate, then all you need to do is just subtract their x-coordinates. The larger x-coordinate minus the smaller x-coordinate. Or other words, the absolute value of the difference between their x-coordinates. And likewise, if the 2 points are stacked vertically one on top of the other, meaning they have the same x-coordinate, then all you need to do is just take the absolute value of the difference between the y-coordinates to get the distance. So let's go ahead and calculate another distance between 2 points. Suppose we're going to calculate the distance between 2, -4 and -1, 3. We're going to use this formula for the distance between 2 points and just plug in what, -1 for x of 2 and 2 for x of 1. So we have -1 minus 2 squared plus, and now the difference between the y-coordinates, 3 minus -4 squared. And simplify, -1 minus 2 is -3 squared, which is 9. And you have 3 minus -4, which is 7 squared. So under the square root sign, you'll have 9 plus 49, which is 58. The square root of 58, well, we really cannot simplify square root of 58 anymore. But if you would like a nice decimal approximation, you can plug that square root of 58 into your calculator and get a nice decimal approximation, 7.62. So 7.62 units is the approximate distance on the plane between these 2 points. Here's another problem for us to take a look at. Suppose that we've got 2 points A, B, and C with the points' respective coordinates. Let's go ahead and do a couple of things with these points. First, let's plot the points, and we'll see that the points form the vertices of a triangle. Call that triangle ABC. And then find the length of each side of the triangle. And what do you notice is so special about that triangle, okay? So here we have plotted the 3 points. Here's your -2, 1. Here's your 2, 3, and your 3, 1. Yes, indeed, those 3 points form the vertices of a triangle. I've got a question for you. Is that a right triangle? Well, to answer that question, let's find the length of each side of the triangle by calculating the distance between each of the 2 points. So first of all, the distance between A and B, that's going to calculate the distance on this leg of the triangle. So we have what? The square root of 2 minus negative 2 squared. That 2 minus negative 2, that's the difference between the x coordinates, right? 2 minus negative 2 squared, that's 4 squared, which is 16. And then the difference between the y coordinates, 3 minus 1 squared, that's 2 squared, which is 4. So we have the square root of 16 plus 4, which is the square root of 20, which is 2 root 5. Likewise, we calculate the distance between B and C. And going ahead and plugging in those numbers, we have the difference between the x coordinates. Maybe we can do 3 minus 2 squared, or 2 minus 3, which is negative 1 squared. Same thing, that gives you 1, which is the square of the difference. And then the distance between the y coordinates, 3 minus 1, or 1 minus 3 squared, is 2 squared, is 4. 1 plus 4 is 5, so you have square root of 5 is this length of this triangle here. And finally, the distance between A and C, and you could see the arithmetic there, and that works out to be 5. All right, so we've got 2 root 5, we got root 5, and we got 5. Is this a right triangle? Well, if this triangle is a right triangle, if and only if the sides obey the Pythagorean theorem. Remember, the Pythagorean theorem says that the sum of the squares of the lengths of the 2 legs would be equal to the square of the hypotenuse. And indeed, if you were to square the 2 root 5 plus the square of the square root of 5, you would get 20 plus 5, which is 25, which is 5 squared. Okay? So indeed, those sides of this triangle really do satisfy the Pythagorean theorem. So the answer is yes. Because the sides obey the Pythagorean theorem, this triangle really is a right triangle. We just got done verifying that. Okay? That's how we do it. What is the area of this triangle? So we know the lengths of the legs, and we know that the area of a triangle is 1/2 times the base times the height. So if we want to know what is the base, well, that's going to be the longer of the 2 legs. That's the 2 root 5. And then the height is the shorter leg, because it meets the base at the right angle. So that height is square root of 5. So you have 1 times 2 root 5 times root 5. Of course, the half and the 2 cancel, leaving you with root 5 times root 5, which is 5. As in, the area is 5 square units. Okay? Moving along here. Let's now talk about using the midpoint formula. As in, we have some point here and some point here on the xy plane. And then, can you tell me what the coordinates are of the point that's exactly halfway between point A and point B, provided that you know the coordinates of A and coordinates of B? And it'll turn out that the midpoint coordinates is nothing more than the average or averages of the coordinates of A and B. Now here's how this looks like. We have point P1 and point P2, and we have midpoint M. Now suppose that point P1 has coordinates x sub 1, y sub 1. And let's suppose that we have point P2 which coordinates x sub 2 with coordinates x sub 2, y sub 2. Now midpoint M, let's just suppose it has coordinates x comma y. Now what do x and y have to be in order for this point to be exactly midway between P1 and P2? So imagine that we create point A and point B out here, off to the side. Point A is going to be directly below the midpoint M, so the same x coordinate as M, but it's going to be x units with or the x coordinate of x. And likewise for B, that's directly below P2 with y coordinate of y and x coordinate of x sub 2. So your midpoint M is going to have the same x coordinate as A and the same y coordinate as B. And the length of this line segment here is going to be the same as the length of this line segment, which is the same thing as saying is that this horizontal line segment here is the same as the length of this line segment there, this horizontal one right there. So that means that, you know, x minus x sub 1, which is what we're saying here, is the same as x2 minus x, which is this right here. So what does x have to be in order to satisfy this equation? Well, we know how to solve algebraic equations. X sub 1 and x sub 2 are two fixed numbers, and x is our variable. So solve for x. Maybe add x to both sides, and add x sub 1 to both sides. So now you have 2 times x sub 2 times x is equal to x1 plus x sub 2. And then divide both sides by 2. So you see indeed that x is really the average of the two x coordinates of P1 and P2. And likewise, we can make the same argument with the y coordinates. And it turns out that the y coordinate y of the midpoint is going to be the average of the y coordinates of P1 and P2. So indeed, the coordinates of your midpoint is going to consist of the coordinates for the the average of the x coordinates and the average of the y coordinates for the 2 points. Okay, so let's go ahead and put this into action here. Suppose that we've got point P1 with coordinates 4, negative 2, and P2 with coordinates 2, negative 5. What are the coordinates of the midpoint? Well, take the average of the x coordinates, 4 plus 2, which is 6, divided by 2, which is 3. Okay? And also take the average of the y coordinates, negative 2 plus negative 5, which is negative 7 halves, which is negative 3 and a half. So we now have the coordinates of our midpoint, 3, negative 7 halves. Okay? And here's a picture of what we just did. Here's point P1 up here, which is coordinates 4, negative 2. And here's our point P2 with coordinates 2, negative 5. And indeed, here's our point M with coordinates 3 and y coordinate negative 7 halves. It's a little bit distorted on this graph, but it's pretty much there. Okay? All right, so that is it for this section. Well, next lecture, either later today or tomorrow, today is Thursday the 13th, I am going to start talking with you regarding graphing functions. As in, y is a function of x, what does that mean? And what exactly is the graph of a function? Okay, so we'll see you next time.